Welcome back to Field Trip Nation. If you like this video, please like and subscribe because it really helps us a lot. How is it possible that a living tree can become a rock? Today we are going to explore how a fossil known as petrified wood is made. When an organism, usually plant material, though other organisms can become fossilized, dies and is quickly buried by sediments such as mud, silt, and ash, it is protected from decomposition by oxygen, bacteria, and fungi. Over time, water-rich dissolved solids flow through the sediment, replacing the original material with silica and other dissolved minerals. The liquid minerals slowly form a solid and create a fossil of the original bark, wood, and xylem material. The petrified wood will often show preserved details of the bark, wood, and cellular structures exactly as the organism looked when it first died.
Alright, so this is a piece of petrified wood. And you can see on the inside it really does look like old decaying wood, but it actually is a fossilized piece of wood where the wood has disintegrated and what is then formed, what has slipped in was the various liquids that have salts and dissolved sand, or not dissolved sand, but dissolved salts and dissolved liquids that form the sediments that replace the original wood. And this looks like real wood, but it's actually really, truthfully, completely, it is a solid rock.
Petrification starts with a tree, and that living tree then has to die. That dead tree then will lose its branches and sometimes its bark, and then the river or the water body it sits near will undercut the soil of the dead tree, and the dead tree topples into the water. The log is then transported down the river or through the lake, or in some instances the ocean. Once the log has been transported through the water body, sediment starts to cover up the log, and this rapid burial seals the tree away from bacteria and oxygen, preventing decay. The minerals dissolved in the groundwater percolate through the logs and deposit the minerals into the cavities of the original log. At this stage, silicic acid enters the waterlogged tree and chemically alters the wood into opal, which replicates the features of the wood. This stage is fairly quick and can take only a few thousand years. As the log gets buried deeper, it enters a dewatering and recrystallization stage, transforming the opal into solid crystalline quartz. This process can take millions of years, but the result is the beautiful petrified wood. Petrified wood, like many rocks and stones, is composed mainly of the mineral quartz. Quartz, or silicon dioxide, is a molecular network of one silicon atom and two oxygen atoms, which will form SiO2, silicon dioxide. Although quartz is colorless in its purest form, petrified wood can be so colorful because it contains trace elements such as iron, which produce a variety of colors from black to pink to red to yellow to orange to green to blue and purple. Once the dewatering and recrystallization stage is complete, the density of the wood can be between 160 to 200 pounds per cubic foot, or 2,500 to 3,200 kilograms per cubic meter.
So this piece right here weighs about 15 pounds.
The fossilized log will slowly weather through wind and water erosion out of the surrounding rocks. It can also come out of the surrounding rocks through the gradual uplifting of the land when mountains are formed. The petrified wood that you see lived between 210 and 227 million years ago at the dawn of the dinosaurs. Quartz crystals within the logs cannot be used to date the logs themselves. We can date the rocks that contain the wood by using zircon, a radioactive mineral found in those rocks. The zircon crystals came from volcanic ash deposited during the Triassic period. Zircon incorporates uranium into its structure but strongly rejects lead. Since uranium is unstable and decays into lead, by determining the ratio of lead to uranium, we know that our fossil forests were alive 210 to 227 million years ago. If you notice the logs from the petrified trees, they look like they've been broken or cut into large segments with a saw. The quartz within the petrified wood is hard and brittle, and it fractures easily when subjected to stress. It is thought that during the gradual uplifting of the Colorado Plateau, around 60 million years ago, the petrified trees that were buried endured a huge amount of stress that they broke as if they were cut. The crystal nature of the quartz created clean fractures and evenly spaced along the trunk, giving the appearance today of logs that had been cut with a saw. These rocks that 200 million years ago were trees that lived in a tropical rainforest and supported many life forms, now support other forms of life in their current state. With a spectrum of colors, the petrified logs once again have lichens and moss growing on them. Lichens are a combination of both algae and fungi working together in a symbiotic relationship. Moss are a small, fuzzy green plant with no roots that grows on trees and rocks, often on the north side in the northern hemisphere and on the south side in the southern hemisphere. Thank you for coming along with us on this latest field trip. If you like this, please like and subscribe. It really does help us.